Hello, everyone. Welcome to today's Skill Up series session. My name is Emily Springer. I'm a graduate learning specialist in the Graduate Studies Support Center, and I am thrilled to be able to partner with one of my fabulous colleagues, Rachel Brune, who works in the Academic Success Center. She is here presenting her statistical analysis series, Dependent Samples and T-Tests. I am just going to do a couple of brief housekeeping items, and then I will pass this right on over to Rachel. Keep in mind that we are recording today's session, and we will post it in our Skill Up series section on our GSSC Center. I also have a YouTube channel where we post our videos as well, and so feel free to subscribe to that and never miss a Skill Up. We also want to make note that conversation is absolutely welcome in the chat, and Rachel will pause as time permits to take questions. If you do have questions, please don't hesitate to put them in the Q&A of the Zoom. If you have questions about how to access that, you can find me in the chat, and I will help you with anything that you may need, technically speaking. And keep an eye on what's going on in the chat and the Q&A for our presenter today. Rachel, that about does my housekeeping items, and I think we're all a little excited to learn from you today.
Well, I'm very happy to be here and presenting again, and hopefully this one is just as informative and helpful as last time. So as Emily said, we are going to be taking a look at the dependent samples t-test. So today, the plan is we will go through when to use this test, the assumptions of the test, these are like the prerequisites, how to actually conduct the test, and then how to interpret the output. And then the last piece would be reporting the results. So how do you tell the reader what those results say? So when do we use the dependent samples t-test? And notice I emphasized dependent. We're going to use this test when we want to compare maybe like one group of people at more than one point in time. This would be like if I wanted to introduce maybe a reading intervention. I would measure the baseline reading abilities, introduce the intervention, and then measure those reading abilities again so that I can see what sort of change happened as a result of that intervention. Since I'm using the same group of people at both points in time, they are dependent samples. The other instance is called matched pairs. It's the same idea, but in this case, there are two different groups of people, but they are linked to each other. We see this in like twin studies. So if they're looking to see how much of a genetic component something has, they might have one twin get an intervention, the other twin not get an intervention, and then compare the performance for those two twins. And this is a little different. We talked about independent samples before. The difference in this scenario is that the two people are linked. So a person in one group is directly linked to a person in the other group. So when we're looking at their data, I'm not just looking at all of group A compared to group B. I'm looking at this person in group A compared to this person in group B. And that's what makes it a dependent sample or a matched pair. Sometimes we call this paired samples t-test. Basically, what we're doing here, rather than looking at, is there a difference between the groups, we're looking at the distance or the difference between those two groups and seeing if there's a significant difference in those differences. Thank the math people for not coming up with unique words for these, because difference of differences can be really confusing. Think of difference as subtracting. So if I take the score for group A, subtract group B, that is the difference. And I'm looking to see if those differences deviate from what I would expect to see. And we're going to look at that a little bit more, but I kind of want to throw that out there now. So when we are working with a dependent t-test, we might see a null hypothesis saying that the difference between the groups is not different from 0. Let me explain. If I give a reading intervention and it does not help with reading ability, and I took your pre-test reading score and subtracted your post-test reading score, I would expect on average to find 0 difference. So if you got a 23 before the intervention and the intervention did not help, I would expect that you're still going to get a 23, give or take, after the intervention as well. So 23 minus 23 is 0. That 0 is indicating that there was no change resulting from that intervention. And that is what this null hypothesis is saying. It's saying that that mean difference between point A and point B is not different from 0, indicating that there was no difference there, no change, no meaningful change. The alternative would then be that there is a difference from 0, indicating that there was some sort of a change, whether that's an increase or a decrease. It's just no longer equal to 0. So let's talk about the assumptions of the test. And again, assumptions are like prerequisites, like a checklist that we have to say all of these items are met and therefore this test can be conducted. So the independent variable must be 2 related groups or a matched pair. The dependent variable must be continuous. There can be no outliers in the differences. The differences must be normally distributed. And we're going to talk about these. So if you listen to that list and you're like, what does that mean? Let's talk about them one at a time. So for our independent variable, this has to be like a repeated assessment, 1 group, providing 2 scores that we're going to compare, or those matched pairs. This assumption can be met by justifying it based on your research design. So simply by indicating that this group of people is going to get measured at 2 points in time, therefore this assumption is met. That type of thing. There is no test that you do to show that the assumption was met. It's justified based on your research design. And then our dependent variable should be continuous. So that would be an interval or ratio level of measurement. I'm not going to go super in depth. If you're not familiar with levels of measurement, check out the charts and variables group session that the ASC hosts. But it's basically a numerical scale. It must be quantitative in nature in order to be appropriate. Again, this is not a test that we can conduct. It's justified based on how you are measuring the variable. So you're going to explain that operational definition and use that to justify that it meets the requirements of being interval or ratio as a level of measurement. And you want to make sure that at both points, whether it's 2 matched pairs or it's the same group being measured twice, that whatever your measuring instrument is the same thing. So if I'm measuring reading ability, for example, I can't give one reading test pre-test and then a different reading test post-test. It has to be the same reading test both times in order to have a meaningful comparable score. So our next assumption is about the outliers. An outlier is an unusually large or small value that doesn't follow the pattern of the rest of the data. There's a few different methods that we can use to identify outliers. Some are visual, like a box plot. Others are computational, using like a math or equation. What we're looking for is outliers in the differences. So we're not going to be looking for outliers just in the general data. We need to compute the differences, plot those differences, and see if there are outliers there. So in this table, we have like a pre-test score and a post-test score. That last column where it has the triangle, that triangle stands for change. So it's computing the change in score between pre and post. I would be graphing that change column and getting something like this box and whisker plot for the changes or those differences. And that's where I'm looking for an outlier. The other assumption is normality. This is again about the differences. So using that table, I would again be plotting that differences column and seeing how it's distributed and seeing if it meets that approximately normally distributed assumption. Again, there's a lot of ways of testing for normality. The more options that you look at to support your determination about this assumption, the better. So you could use a histogram. You can interpret the skewness and kurtosis values. You could interpret the KS test or Shapiro-Wilks value. You could use QQ plots or any combination of those to say that this assumption has been met. And if you're not familiar with a normal distribution, that is that bell-shaped curve. So it's got like that peak in the middle, and then it gradually tapers off to the tails. So a common question is, well, what do I do if these assumptions are violated? Well, you could consider adjusting your data, maybe doing a transformation or bootstrapping and seeing if that helps to fix that violation of the assumptions. You could do some research and see how robust is this test to violations of the assumption. I'm going to talk about that a little bit more when we get into the data, because you'll see that the data that I'm going to use does overtly violate some of these assumptions. So if the test is robust to the assumption, essentially that means like there can be some violation of the assumption and the results will still come out the same. And generally that's okay. There is not a cutoff point. There is no rule that says, well, it's robust to this point and then it's no longer going to be appropriate. It's up to you, the researcher, to determine, is the violation severe or not severe enough that I could say that we can still proceed? And that's a call that you'll make based on your review of the literature and what it says about how to handle it. The other is that you could just change the test. So like normality is a commonly violated assumption. If the normality is violated, you could do a non-parametric equivalent like the Wilcoxon matched pairs test. That one does not hold an assumption of normality, so you might be able to do that test instead. These are just some of the options. We are not going to go into most of these, but I would encourage you, if you're in a position, don't jump straight to change. Explore those other options first, because that may allow you to salvage your data that you already have and allow you to continue with a parametric test, which has a lot more generalizability than a non-parametric. So consider the other two options before jumping straight to, oh, I just can't do it, and do something else. So this is where I'm going to transition into doing the test. So I'm going to pause here and see if anybody has questions about any of the assumptions that I talked about, if there's anything that I can clarify about those assumptions.
Thank you so much, Rachel, for the quick pause. I'm just going to wait to see if there's any questions from the assumptions that you just covered. Remember, you're more than welcome to put them in the Q&A. And if time permits later, we can always raise our hand as well too. Right now, Rachel, I don't see anything in the chat or the Q&A about the assumptions.
Not a problem. All right. So
Oh,
go ahead.
sorry. Okay. So sorry, it just happened. Oh, someone had mentioned I believe you just mentioned the Wilcox
Mm-hmm.
test.
Mm-hmm.
The question is, what is the Wilcox test? Well, it says something different, but I believe that's the question.
Yeah. So
Oh, sorry. It says, do not explain, if you can just spell what is the Wilcox.
Wilcoxon matched pairs test. It's up here.
Oh, right there.
Yeah, it
on
is
the right hand side.
Yeah, and well, if I can
Highlight.
make my computer listen here.
I will spell it right here too in the chat.
Well, I'm trying to draw and trace it, and it's selecting my pen, but it's not letting me draw. I use that all.
No
There
worry.
we go. Now I have my little thing. All right. So it's over here. So that's the Wilcoxon matched pairs test.
Thank you so much, Rachel. Yeah. I did pop that in the chat. Thanks,
Okay.
Laura, for your question.
So the data set that I'm going to use, and I do this intentionally, the data set is available in SAGE Research Methods. So if you go to the library, to the SAGE Research Methods datasets database, and that's a lot of data words, they can help you if you need help finding it. But if you go to that database and you look for a paired samples t-test, it will connect you with a bunch of results, one of which is the one that I'm using here, citation included. But it's the World Bank open data example. So I'm going to be using this data. I love the data sets because it gives you like a student guide where it gives you information about the test and the assumptions and things like that. Being transparent, I did feel like this guide was less helpful than the independent samples guide. I did not feel like it went through the testing of the assumptions and interpreting the graphs the same way that they did in the independent samples one. I think it's specific to this particular data set, but I just want to throw that out there. They do have a lot of great resources. I love that the data set is available to you and you're able to practice and compare your results with their results. So that is the data set that I'm going to be using. So let me get on here. All right. So this is my SPSS. And if it's messing with your eyes, don't worry, it's messing with mine too. There's a lot of decimals in this one. So the first thing that we need to do is start checking for our assumptions. Now, I did not collect this data, so we are going to go ahead and assume that our independent variable and dependent variable assumptions are met. I can confirm the independent because we can see here is each country, and each country was measured at multiple points in time. So if I choose 2 of those points in time, I know that data came from the same country at both points. So I can confirm that the independent variable is matched. As far as the dependent variable, I will trust that these are truly scale. I suspect that they are, since they are decimal values, that indicates that they fall on a continuous scale. So I think that we have reason to assume that those assumptions are met. And then we're going to move into looking for those outliers and checking that normality. If you remember, I said that we are going to be checking those for the differences, which means I actually need to compute that first. So we're going to do something new. We're going to go into our data, or the transform, and we're going to click where it says compute variable. For the target variable, this is asking for the variable name. I like to be basic. I'm going to call it difference. So I know what this variable is. In the numeric expression box, this is where I'm going to enter the expression that tells SPSS how to do the computation. I'm looking to compute the difference between 2 points in time. When we're doing a dependent t-test, typically the order of that math is second value minus first value. So if I'm doing pre-test, post-test, I will be taking the post-test score minus the pre-test score. So for our example, I am going to deviate from the guide, and I'm going to take 2016 minus 2006. So I'm going for a 10-year overview in my example here. Notice I just clicked on the variable and then clicked the arrow to move it into the numeric expression box. So now my expression says 2016 minus 2006. I'm going to click OK. It's going to pull up the output window. I don't actually care what's here because it's not going to give me anything. What it did, if I scroll to the right here, it generated a difference score. So it computed the difference for those columns and gave me those values here. Now that I have my differences, I can check for outliers and normality. There are many ways of doing this. I prefer trying to do as much as I can in a single step. So I'm going to go to Analyze, Descriptive Statistics, Explore. For my dependent list, I'm going to place my difference variable. I will leave the other two boxes blank. And then I can choose my settings. I encourage you to feel free to click on these and just see what's there. Get familiar with the options. You can't break SPSS just by clicking on a box. So I'm going to look and see what statistics options I have. The default is descriptives, and I want to keep that selected. We have the mean estimators, outliers, and percentiles as options. I am going to check the percentiles box, and I will explain why in a minute. You don't have to. You could choose to check the outliers box. I choose not to because it doesn't always list all outliers. Sometimes it'll only pick a certain number of outliers, like the most extreme 3 on each end or something like that. So generally, I do not select the outliers box. I will rely on other methods for identifying outliers than that box. So once I've selected my options, I will click Continue. I'm going to go into my plots. Here, I'm going to uncheck stem and leaf because I definitely do not want that. I am going to check the histogram box. It'll allow me to check that normality assumption. I'm also going to check the box next to normality plots with tests. This is going to give me some of those other measures I talked about, like the Shapiro-Wilks and the QQ plot. So I'm going to check that. It'll give me a lot of methods of analyzing that normality assumption. And then I'm going to click Continue. In this case, there aren't options that I want to select. I'm going to keep missing values the same. I'm not doing any bootstrapping, so I'm not going to use anything in that option either. Once I have my settings selected, I'm just going to click OK. And this is going to generate everything into my output window. The case processing summary really isn't relevant in most cases. Unless you have missing data, then it's pertinent. In this case, I don't. So there's really nothing of value in that box. My descriptive statistics are where I'm going to find information about like the mean and standard deviation. It's also giving me the skewness and kurtosis, which I talked about as things that we can consider when evaluating normality. So skewness in this case looks okay to me since we're not that far from 0. Kurtosis at 15 definitely seems like a red flag. I'm thinking our kurtosis is off. Kurtosis is talking about how tall and skinny the curve is as opposed to low and flat. Skewness is talking about that peak, if it's off to one side versus in the middle. So this kurtosis score tells me that my peak is in the middle, but it's not the right shape that I'm wanting, which isn't a huge deal, but it is something to be aware of. So then if we scroll down to our percentiles, I'm going to ignore this right now because I only wanted those for a specific reason. We're going to look at our test of normality. Here is another checking point for that normality assumption. These are both appropriate for different sample sizes. In this case, they're both in agreement, so it doesn't matter which one I interpret. These, however, are comparing to perfectly normal, which is never going to be the case. But that is important to know because our assumption is approximately normal, which means it doesn't have to be perfectly normal to still meet the assumption. So I am going to consider these scores because they are significant. So this significance value on both of these is less than 0.001. That tells me this is significant. That tells me that my distributions deviate from normal significantly. Basically, they aren't normal. They aren't perfectly normal. So thus far, my evidence seems to point to not meeting this assumption. So now we can start looking at some of those graphs and visuals. So looking at my histogram, I'm looking for normality. I immediately see these unusual values. They are disconnected from this curve by quite a bit. So that is absolutely pulling on my normality. I can also see this is a very tall, skinny peak. That's why my kurtosis value was so high, because my distribution is very narrow. So this supports that my assumption here at this point is not met. I can go on to interpret the QQ plots. Basically, what we're looking at here, this diagonal solid line is representing normal. So if my data is normally distributed, all of those dots will lie very close to that line. And for most of it here in the middle, it actually looks pretty good. Again, it's these other values that are pretty far off that line. So based on what I've looked at, and there are other graphs, and you don't really have to look at those. At this point, I have enough evidence to suggest that my assumption of normality is not met. I have options, and you'll notice that these are what I would call outliers because they don't fit with the rest of that data. And if I go down to my box plot, I can see that, yes, we do have some outliers here. We actually have a lot of outliers. All of these circles and then all of these here are also outliers. And that's the good thing with the box plot is anything that SPSS flags as an outlier will be marked on the graph. So you can visually see that there are outliers. For the purposes of our demonstration, I am not going to resolve all of the outliers. There are methods for that. In the independent samples group session, I did talk about one method for doing that. It's called Windsorizing, where essentially you look at the highest value that is within that distribution and then add 1, and all of these upper points up here would be replaced with that slightly higher value. And then you would subtract 1 and replace all of these with that value. That is one method for dealing with outliers. There are pros and cons to using that method. So throwing it out there as something to research if you're in a position where you have outliers and you're like, what do I do? For this one, I'm going to go with another option. And that is, I'm actually just going to remove the 2 most extreme outliers because they don't fit into that distribution. So when I was looking here at my graph, there are 2 points that are very clearly far removed from the rest of the distribution. So I'm going to just eliminate those 2 and keep everything else in. Really quick way of doing that, I can look at the numbers on the graph. So one of my outliers is data point 145. The other one is 13. So I'm going to go back to my data set. I'm going to start with the bottom one. So I'm going to go to 145, and I'm just going to remove it. You might choose to do a different method with your data. For our purposes, I'm just going to delete them. Same thing with 13. And then I'm going to rerun my statistics. Everything is already set the way I ran it before, so I can just click OK. And I have new values. Notice my kurtosis value is 4. Still not where I want it to be. However, it's much closer. And if I'm going for that approximately normally distributed assumption, this is much better. We see that the KS test and Shapiro-Wilks are still significant. So I'm still significantly different from perfectly normal, but I'm going for approximately normal. Looking at my histogram, it looks a lot better. Now that I've removed the extreme outliers, I can see that this tail is a little bit flatter than this tail over here. And that's why I'm still not quite hitting that normality assumption perfectly. But it does look a lot better than it did before. And we see the same thing with the QQ plot. This upper tail fits really well to that line. Yes, there's some deviation, and there will be. That's why the assumption is approximately normal. We see more deviation on this end. I could take more time, continue to clean this up. I could try bootstrapping or transforming to get it to fit that normal curve better. But at this point, just from deleting those 2 items, I'm pretty satisfied with the distribution that I have going on. So even though it's not perfectly normal, I feel comfortable saying that it's normal enough to proceed. There are still outliers. One of the things that you could do at this point, I'm going to proceed with the outliers in play. You can do that. You can also remove the outliers and run the test again to see if the presence of the outliers significantly impacts the outcome. So am I finding significance with the outliers, but not finding significance without the outliers? If that's the case, then I might definitely want to consider other options for analyzing my data. If they both show significant, for example, or if they're both showing not significant, then I can feel more confident that those outliers really aren't impacting the outcome. So I'm going to just keep the outliers in for our analysis. So at this point, we have worked through all of our assumptions, and we have the data at a point where it's a better fit for the test. So now we can run the test. We're going to go to Analyze. We're going to Compare Means. I'm going to do the Paired Samples t-test. And here I place variable 1, variable 2. When SPSS does the difference, it will take variable 2 minus variable 1. So I want to place, I want to place the 2006 and then 2016. It automatically acts as if I have more pairs. You want one pair, variable 1, variable 2, as it appears here. You probably will not modify any of the options. We aren't bootstrapping, so we don't need to use the buttons on the right. I'm going to keep the effect size estimate box checked. You can uncheck it if you don't want it. You'll want it if you have significant results. You'll want to explore when to use each of these different options. So it has to do with the data and what's most appropriate for that fit. I'm going to keep the default standard deviation of differences. And then we click OK, and it will run our test for us. So looking at our paired samples statistics, this is just the descriptive statistics for the two variables that I chose. So here I can see the mean and standard deviation for each of those years. And just at a glance, comparing the 5.87 to 2.88, I can see that 2016 numerically is lower than 2006. So whatever this variable is that I'm measuring, it is lower in 2016 than it was in 2006. I don't have enough information yet to be able to say that that difference is significant. And that is important to remember. If you think back to those hypotheses, I was talking about being different from zero, that difference between the two scores not being the same as zero. It's never going to be exactly zero. So we know that there is some flexibility around zero that still doesn't indicate that the two groups are different. That applies here. I can look at 5.8 and 2.8 and say, well, 5.8 and 2.8 aren't the same number. And I would be correct, but I can't say that they are statistically significantly different. And that's what's important. I need to look at the test to see if the difference that I'm seeing in the numbers is a meaningful, significant difference. So if we come down here to our paired samples test output, we can see the mean. Let me grab my pen here. So our mean is the mean difference. And basically all they did was subtract the two. And then we can see the standard deviation. And again, that's the standard deviation of the differences. What we really want to look at for our test is our t-value. So this is my test statistic. If I was going to be reporting this, I would say t with 229 degrees of freedom equals 9.917. And then my p-value as reported here is less than 0.001. Now you'll notice there are two options, a one-sided p and a two-sided p. You will need to know if your test is a one-tailed test or a two-tailed test. Again, I'm not going to cover that in this section. There is a hypothesis testing group session that the ASC offers that does go over that. So if you're not familiar with one-tailed versus two-tailed, definitely jump into that session and it'll go over that more. For our purposes, it's a two-tailed test. But in this case, it doesn't really matter. I'm coming to the same conclusion either way. So because my results are significant, I can interpret my effect size. In this case, we will use Cohen's d as a measure of effect size. The point estimate is the value that I care about, so 0.654. In order to know what that means, you'll need to know how to interpret Cohen's d or whatever effect size is appropriate for your test. This one follows the 357 rule. So if it's 0.3, then or around 0.3, anything less than 0.3 is basically a negligible, weak effect size. 0.3 is considered small. Once we get to 0.5, it's considered moderate. And at 0.7, it's considered large. So we are just on the brink of a large effect size with an effect size of 0.654. An effect size is like a real world impact, I guess. So I know that there was a significant change from 2006 to 2016, but like, does it really mean anything? I think the best example of this would be like if you are doing like drug trials and you introduce a new medication and you find that your medication is significantly better than the existing medication on the market, but the effect size is small. That would be the equivalent of saying, oh, our blood pressure medication does a better job of lowering your blood pressure. And the small effect size means that it lowers your blood pressure 1 or 2 points more than the existing medication. So that small difference is significant. It is doing it significantly better, but it's only 1 or 2 points. So that's really not going to have a huge impact on your overall blood pressure level. So hopefully that helps clarify what that effect size is. Questions on the test and interpreting the output?
I'm just going to wait just a moment or two. If someone does have a question, please feel free to raise your hand and or put it in the chat, the Q&A as well. Just going to wait just a moment, see if anything trickles in. It's a lot of information covered, so
Yes.
if something does come up as you move forward, Rachel, if it's all right, I will interrupt you if it's in relation to what we just covered.
Absolutely. So I'm gonna open up Word here.
Yep. Question just popped up in the chat.
Go for it.
Do you reject the null hypothesis? And Lisa, I'm assuming that you're discussing what just occurred in this last sample, right?
Yes.
Okay.
We would be rejecting the null hypothesis in this case.
Lisa gives a thumbs up. Great.
So I'm gonna make this font bigger so you guys can see it. Okay. So the last thing that I wanted to touch on was, how do we report these results? It's really going to look different depending on if you're doing a dissertation versus doing an assignment. But I have a general format that I typically try to go with. So I'll start by identifying what test was conducted and kind of indicating the purpose. For this particular data set, because I don't really know what this continuous variable is measuring. So I'm going to make that part up. But I'll say something like the dependent samples t-test was conducted to determine if the change in, we'll say GDP, has, all right, determine if there has been a significant change in GDP since 2006. So just a sentence saying what test I did and what the purpose of the test is in the context of the variables that I'm using. There's other things I could include here, like providing some descriptive statistics, so indicating the mean and standard deviation for each year. If you're doing the dissertation, that's in an earlier part of the chapter, whereas reporting the results are in a later part of the chapter. If you're doing an assignment where it just says to write a results section, you could totally incorporate that here. So you could say the descriptives, and I'm just going to put this sentence in here for 2006. We'd have our mean and our standard deviation. I just don't want to take up too much time putting all of it, but you could plug that information in here, providing those descriptive statistics. Again, not to say that these are different, simply saying, here was the average for this year, here was the average for this year, to give a reader the idea of where we're starting. And then we can indicate the results of the test. Showed that the GDP had significantly declined. And I can say declined because the average was higher in 2006 than 2016. So it declined from 2006 to 2016. And here's where I can include those statistics. So I would have my T-score and my degrees of freedom, which was 229, I think. Yeah. And that was 9.917. And my P was less than 0.001. So I could include these statistics in here. And then I can incorporate that effect size and say, this was a moderate to strong effect. And then I can include that Cohen's d value here. Any questions? I will open it up at this point for any questions on anything that I talked about.
Awesome. Can we, since we're here, and we have a little bit of time, can we peruse over to the Academic Success Center?
Yeah.
So they can see some of the resources that are from the statistics area. Just another question. If a student did want kind of a one-to-one tutorial to go over specific data for their dissertation, is that a resource offered through Academic Success Center?
Absolutely. You can use the coaching scheduler over here to schedule an appointment. Sometimes those appointments look like they're booked. So if you don't see one for the week, you can use our live chat over here, or just submit a ticket here, and we can help you get one of those appointments scheduled. But yes, absolutely. You can schedule an individual session with a stats coach for help with like cleaning up the data. So how do I know if I should delete these outliers or Windsorize the outliers and things like that? We can help with that whole process and getting into conducting the test, interpreting the results, and all of that stuff. So absolutely.
Thank you so much, Rachel. Yes, I was going to definitely suggest that coaching scheduler, taking advantage of that. And then as our attendees can see right here on the self-directed resources, you can find statistic resources as well through the Academic Success Center.
Yes.
We'll wait just a few more moments as we kind of like show you the ropes and the statistics portion of Academic Success Center to see if you have any other additional questions. But Rachel, so far you've covered a lot of really great material and provided wonderful explanations of how to move through the dependent t-test. So
we have guides here. You can get information about the dependent samples t-test, resources and information on testing assumptions and things like that. If you wanted to learn more about that hypothesis testing, so one-tailed versus two-tailed, making a decision. So am I rejecting or failing to reject? We have pages for all of that as well.
And Rachel, I just another question that popped up in the chat as we were discussing those one-to-one tutoring sessions.
Mm-hmm.
You know, would that be the same type of tutoring for the statistics course that is in our current doctoral program of study? So, for example, as you mentioned, there's that one-to-one tutoring, but our coaching scheduler also offers group sessions for statistics as well, correct?
Yes.
Great. So my recommendation would be if you have joined, if you've just recently started statistics and you're looking for some foundational tutoring services, please do check out that coaching scheduler and the statistics portion of the Academic Success Center. I'm
Yes.
scrolling down. I got several more questions. Let me see, Rachel, if you have any other additional thoughts on that.
Nope, just showing the statistics related group sessions that we have on the schedule. And you'll notice as we get into the SPSS group sessions, there is an SPSS session for t-tests. So that would be a good one to join. Group sessions really kind of depend on who's in the session and what those needs are. It's regardless of the approach, it's a great opportunity to see some of these skills in practice and learn different strategies and things like that. All of those are recorded, so you could always go back and watch that session again later. So it's never too early to join any of those, even if you're not doing it in class yet, just because there's nothing worse than, like, this one's on a Tuesday, which is great, but this one's on Friday. So imagine that you're working on correlation or regression for your assignment that's due Sunday, and you can't get into a session to learn about it until Friday. So it's never too early to jump into those, even if it's just simply to have access to that recording. So if you need it later, you have it when you need it.
I'm so glad that you mentioned that, Rachel, just because someone in the chat just mentioned, I haven't yet started statistics, but I want to, kind of get their hands into it a little bit, understand it a little bit more before it begins, which is great too. And Rachel, as Rachel just mentioned, please, don't hesitate to utilize these group sessions as well too. Let me scroll on down. Several people said, thank you so much. This is wonderful. Oh, okay. If they wanted to join the group session, Rachel, all they would need to do is look at the description and then click on the words that say, coaching scheduler, correct?
Yes.
Okay.
And your view will look different than my view, but
oh yes, because you're
as a student view, it's going to look different than my view. For the most part, it's the same. You'll just see some different colors. But what I suggest is where the display options are, just going and selecting group session.
Oh, so it pulls them up.
Yes. So that's going to make the schedule a lot easier to look at because it's not going to have 500 appointments. It'll only have 50 appointments, right? So then you just look for the name of the session. So if you wanted to join the t-tests, you would find that row and then go over to the space. When it's white, that means you can schedule it. So then you would click on that space and then you're going to fill out this form here. It's going to have this box for an attachment, and this is a little deceptive because it seems like it's saying it's required, but it's not. It's only required for asynchronous, which this is not. So even though it looks like you are required to attach a file, you are not. You can if you want to, but you are not required. So you can skip that if you want to. And then you would just click on create appointment. And then what would happen is this space would turn, I call it school bus yellow. It's like a goldish yellow color. And so you'll know that that appointment has been booked.
Great. And there was another question too for, I'm going to say newbies for SPSS. Just making sure that it's set up correctly. I recommend utilizing the University Service module to access the SPSS software. If you have questions about how to set that software up, there is a guide, but of course you can utilize IT as well. I recently completed statistics a couple of months ago, and I use the IT services to help make sure it was downloaded onto my computer the right way.
Yes, and that's what I would also recommend. If it comes to accessing and installing it, reach out to the service desk for help. Once it's installed and licensed and like you can use it, but you're like, okay, I can use it now, but I have no idea what I'm doing.
Right.
That's where we can help. So that would be like this introduction to SPSS group session. It's a great way to learn about navigating and doing basic things in SPSS. We also have some resources on our, I'm on the groups. I was like, why isn't it on here? On our group session or on our statistics page.
Yes.
So here where it says SPSS tutorials, if we
Absolutely.
click on that, it's going to take us to resources. So how do I enter data into SPSS? And it's got some written instructions for that. And then we can look at other popular topics like how do I create charts and graphs? How do I generate a frequency table? How do I pull descriptive statistics? So we have videos for all of those here. If you get into some of the tests, like how do I do a correlation or a t-test, you'll find all of those tutorials down here with the actual tests. So as soon as it loads, there we go. So there's a video here on how to do the test. So when you're doing the tests, you'll want to look in the tests for those videos. But if you're doing basic SPSS things, then you're going to do the SPSS tutorials.
And I just want to note that as I was completing statistics, I absolutely utilized all of the resources in the statistics center. In the statistics portion of the Academic Success Center, utilized a coaching service, and then also found some resources as well too, just because for me as a learner, sometimes I need to see things in multiple different ways to comprehend the material. And so sometimes I would check out some other resources too through YouTube. Rachel, forgive me. Is that bad if I made that suggestion?
No, my counter suggestion, I have nothing against YouTube.
Okay.
My counter suggestion though would be reach out to us first.
Yes.
Simply because the number of students that I had that are great independent learners utilizing all of those resources like YouTube that are available to them, that come in overwhelmed, frustrated, ready to be done with it because they just spent hours watching videos and it's still not working. It's still not doing what it's supposed to be doing. And it's because YouTube is not diagnostic.
Absolutely.
It can't help you figure out why it's not working. And I talked about a dependent t-test. I talked last time about an independent t-test. If you don't know that there are different versions of the same test and you're like, oh, I'm doing a t-test, and you go and watch a t-test video, if they're doing a dependent and you're supposed to do independent, the steps they do aren't going to be right, and you might not be able to tell. So you could waste so much valuable time exerting all of that energy and getting frustrated on the wrong resources.
100%.
So YouTube is great. And as I was building out our resources, if you go to our t-test page, I don't remember exactly which one of these it is, but on here I have some resources linked that are YouTube videos. I watched them, I vetted them, I know they're good.
Absolutely.
So I do think that YouTube is good. But when you're stuck, or if you've watched a few and it's still not working, don't keep going. Just reach out to us. Let us help you get squared away. I would argue at least 75% of the time, the problem is the data is not entered right. So it's not working because the data is not right. And that YouTube video showing you how to do the test is not going to go through. Make sure your data is set up right and show you how to check for that. So yes, YouTube, good resource, but don't spend too much time there if it's not working. Don't let yourself get too frustrated or overwhelmed. Reach out to us. Let us help you get squared away first, and then you're good.
Absolutely, Rachel. I couldn't agree more with you. 100%. Reach out to the Academic Success Center first. Our coaches are going to be able to assist you with the information that's most pertinent to your program of study. So that being said, I highly recommend utilizing the resources that are available to you in the Academic Success Center, all things statistics. And of course, if you do have other additional questions too, our students can always reach out to academic success coaches through the chat feature as well. Correct, Rachel?
Yep. So it's currently offline, of course it is.
Okay, that's okay.
But you can click here and it'll open a new tab that you can keep track of to chat with us. If chat's offline, we do have our question system, or you can send us an email or even text us. I will say texting is deceptive. A lot of students think of texting as like chatting. So if they send us a text, they're going to get immediate reply. Texting is more like a ticket. So we will get to it when somebody is online to respond to it. So the only method that would give you immediate assistance is chat, and that's if chat is online. So if chat's not online, there is nobody there to give immediate assistance, but please still submit a ticket to us, whether through the ticket system, sending us an email, or sending us a text message, and we will definitely follow up with you as soon as somebody is online and ready.
Thank you so much, Rachel. And, thank you so much to all the attendees today. Some really great questions. And just, Rachel, I don't know if you can see the chat, but so many people said, thank you so much for this session. It's very informative. And of course, we are here to help provide tools, tips, and strategies to help you be more successful in your academic journey. So don't be a stranger and reach out when you need assistance. We're here to support you. Thank you all so much. And I hope you all have a great rest of your day.